So sorry, the battery died, so I had to recharge the battery. So I was telling you that as we increase the resistance, we get to a point that's called boundary conduction mode. At this point, delta IL divided by 2 is the same as the average of the inductor current. If I write the formula for the average inductor current is always equal to IR, which is VO over R. Delta IL, we have the formula, so delta IL is going to be VI 1 over L VI minus VO times dt. Okay, so let me actually simplify this formula. So R, it's gonna be equal to let me just like make sure that I'm doing okay, 2L times VO divided by VI minus VO times dt. Okay, make sure that this is correct. Yes. Okay, so well, like you can write this in different ways, because you can write delta IL from this line, but this is basically what this critical R is. Why is this called critical? Because if we want to use the formulas that we just saw, if we have a fixed inductor and a fixed capacitor, if the value of the inductor is known, we have to make sure that our resistor value is always smaller than or equal the critical resistance. Why? Because otherwise, if you increase the R further than this point, then we're not going to be in the continuous conduction mode. We're going to be in another mode, which is called discontinuous conduction mode, or DCM, right? So everything we saw was for either like CCM or even for BCM, that's correct. But like if you increase R further than this point, then the formula that we mentioned, it's not going to be valid anymore. We have to analyze it, and we'll do it like in another course in 4420. But for now, we're just gonna only do it in the continuous conduction mode. Just to show you what happens if you increase R further than that point, it's gonna look like something like this. If we are in the DCM, we basically, our inductor current start from 0. It goes to delta IL, the same formula that we saw. But before we reach to the end of the period, it hits 0, right? And you guys remember that I mentioned that if there is no current going through the inductor, then this diode is basically open, right? So then there's no current going through the inductor for the rest of the period. So this is like what's going to happen in the discontinuous conduction mode. The CCM, DCM, there are two modes that you can operate your buck converter or boost converter or buck boost converter based like in either of them. Okay, it's not that DCM is bad or CCM is bad. Each of them has its own advantages or disadvantages, but you just like have to, when you design your circuit, you have to know if you're going to be in the CCM or DCM, because like the dynamics of the circuit, the formulas are going to be totally different. The output voltage, it's not going to be D times input voltage anymore in the DCM. Okay. In CCM, you can see that our current, it basically, the changes that we have are at these points, right? Here we have more changes, okay? We have more changes over one period. So we have more harmonics. If we do harmonic analysis, or if we do Fourier transform for these two waveforms, we see that here we have more harmonics. So in the DCM, we end up with more harmonics, and therefore we also like have more electromagnetic interference. Okay, so that's the disadvantage of DCM compared to CCM. However, in many cases, some designers might design their circuit to work in the DCM mode. If your inductor is very small, right? If your inductor is very small, then you can make your circuit work in the DCM mode, okay? I want to do that analysis for you as well. So this analysis for the time that we know what the inductor is, and we wanted to find like what the critical resistance is. Now let's assume that we have a set load, we have a set resistor, right? And we want to find like what's the inductor that we should choose for our buck converter, so that so that like we are in the CCM mode, right? So I'm again gonna use exactly the same shape, right? This time like we have the resistor, we know what our resistor is. We want to find like what's the inductor that we should choose. So again, the same formula that we did before. IL average is equal to delta IL divided by 2. IL average is VO over R. Delta IL divided by 2 is 1 over L times VI minus VO times D times T. Okay, so now like if I know R, I want to find L. It's gonna be R times VI minus VO, that's just like put average here, times DT divided by average VO. Okay, so if I know what my input voltage is and like what I want to have for our output voltage, then I can find the D. I know the resistor, then I need at least this value for my inductance to be in the either boundary conduction mode or the continuous conduction mode. This is called L critical. If we have R, then we can calculate L critical. If our inductor is lower than the critical point, then we're gonna end up with the DCM. Okay, so some people, some designers might want to save some money for their inductor, so they want to use like a smaller inductor, right? But if you use a smaller inductor, it means that your circuit is now going to operate in the discontinuous conduction mode, right? So you have to do